My name is Fen Gao. I'm presenting my final project for Harvard's CSCI E90 Cloud Services Infrastructure and Computing class. My project's goal is to build a cloud-based data processing pipeline for real-time Twitter stream filtered by the predefined keywords. I'll demonstrate how to build this pipeline using cloud services, including AWS EC2, Docker, Apache Flume, Kafka, Elasticsearch, Logstash, and Kibana. This is the longer version of the presentation with more details and conclusions and the lessons I learned. Here's an overview of the architecture. The data source is the filtered Twitter stream. We use predefined keywords to filter the Twitter source. And then in the collection tier, we use Flume to ingest the data in and send the data to the messaging tier, which is a Kafka service. And Kafka service will be used as a message broker for any incoming new events. And then we have a processing tier, which is Logstash service. The Logstash service will subscribe to the Kafka topic and send the data to the Elasticsearch layer, which is our persistence layer. And finally, we have a visualization tier, which uses Kibana to present the data and discover which keywords are popular and the trend in a certain time period and region. Here's the implementation details of this pipeline. We use Docker. Here's the Docker Compose script for Docker container setup. We have a container for Zookeeper service, and also 3 containers for a Kafka cluster, and a container for ELK service, as well as a container for Flume service. And here's the configuration of our Flume service. You can see the Flume service is using Twitter stream as the data source, and it's using memory channel, and the sync of the Flume service is the Kafka service. And here are the predefined keywords to be used to filter the Twitter data stream. And also we have already set up a Twitter developer account that will be used to set up a connection to this data injection pipeline. And after that, here's the configuration script for Logstash service. So you can see that the input of the Logstash service is a topic in Kafka, and we have a simple filtering logic to map the fields as we defined. And then the output of Logstash is a local Elasticsearch service indexed by the topic. Here's the setup steps for the pipeline. Launch the EC2 instance, and we copy all the configuration files over on the EC2, and then we start the containers using Docker Compose script. And then we make sure all the services are up and running, and then we create a topic in Kafka, and then we start Flume to ingest the data from Twitter stream into Kafka, and then we start Logstash to send the data from Kafka into Elasticsearch, and finally we use Kibana to discover and visualize the result. Here's the instance, EC2 instance we used for this project. and we can see that the Docker Compose is up and running, and then we use Flume service to ingest the data in. You can see that some of the Twitter data is already in the pipeline, and while the Flume service is sending the data into Kafka, we have a Kafka console consumer to monitor the Kafka new events. And after that, we have Logstash service started, and moving data from Kafka into Elasticsearch. And then finally, we have Kibana here to run a query on Elasticsearch data, and you can see the data is already in Elasticsearch. And also we can have an ad hoc query running again, it's the Elasticsearch. We run the query by keywords during a certain time frame, run the service, and then you can see the count of the Docker mentions for that specific keyword. That's a quick demo of the project, and also one more thing I want to mention is the conclusions and the lessons I learned. The pipeline is heavily relied on the open source components, ELK, Flume, and also when we run the ELK service on different OS, the service may be unstable. I spent several days to troubleshoot this and figured out that on some of the OS, ELK has some limitations on the max file handles. So we finally used CentOS as host OS for the Docker container. Moving forward, it would be better to have a CloudFormation script with specific version number defined for the pipeline. And also moving forward, if we have more time, I would like to use AWS Fargate to host the containers instead of managing EC2 instances by myself. And also, instead of using Flume and Kafka to ingest the data and have the cache for the data stream, we can also use Logstash own Twitter connector directly to the Twitter data stream instead of adding 2 more layers. Twitter stream has a limitation on the frequency and the volume of the data feed. So for demo purpose, it's okay, but if we want to move this into production environment, we may need to find a mitigation plan. That's all for my project. Thanks for watching. Enjoy the class.